Hi, it's Wednesday today. I actually haven't had a chance to do the video for Monday and for Tuesday. Monday was a bit of a slow day, but so what I'll do in this video is I'll just go over various activities that I've done Monday and Tuesday. Okay, so I got some quotes for bearings. So there's some bearings that I mentioned last week that we need to get for shafts for fans that we're busy manufacturing. And I just received some more quotes from a different company, and this different company seems to be very similar to another company that I got. Our project coordinator wasn't in yesterday, so actually since Monday she hasn't been in, and she's the one who normally does the orders. So we tell her what we want, what we want to buy, we give her the quotations, and we mark what it is that we want to purchase. And then we also give her the necessary phase and the component for the particular project, so that she buys that, she sets up the purchase order so that it gets costed for that particular project on that particular component. And that helps us in the future because next time when we quote the client for a product, we can have a better estimate, or better estimate really, of how much that particular component will cost, plus of course our markup as well. So I got those quotes for those bearings, had a look at them. As I said, they were very similar. I'm also still waiting for a few more quotes, and then also a quotation for that one bearing that takes quite a bit of time for it to be manufactured and shipped in. I'm waiting for that quotation. One of the guys at the bearing manufacturers or distributors indicated to me that he'd be able to get it to us by the end of March. Okay, then I also got bearings for we're also getting bearings for made of Vesconite. So Vesconite is a little bit more is a material very similar to like a plastic material, but it's very helpful for it's very fitting for the application that we have. And what we actually done is we have a flange bearing, and what we do is we push that flange bearing, we push the actual rolling element bearing out of the flange, and we put a Vesconite bearing in there, and we found that actually works better. Well, I personally haven't seen it myself. This is the first I've heard of it, but I ordered the Vesconite bearings, and I ordered the flange units. And the flange units we're actually sending to the person who's manufacturing the Vesconite bearings. And he called me and he said, hey, these things haven't arrived yet, so I had to follow up on that, only to find out that the purchase order that was sent to the bearing manufacturer or the bearing distributor was sent to a person that no longer works there. So the bearings were supposed to arrive, the flange bearings were supposed to arrive on Friday already, but they didn't, and it was because this purchase order was sent to the wrong person. So I called up yesterday. I had to call up the bearing distributor, ask them what the issue was, and they told me that this was sent to a person that doesn't work there anymore. And so I had to send the purchase order to the right person. And when I did send the purchase order to the right person, I found out that the company that I work for doesn't have an account with that manufacturer. And what actually happened is then in previous years or previous months previously, when ordering bearings, it was always done a cash on delivery. They never had an account. So I had to get a cash on delivery for that, and then send it to a cash on delivery invoice, like a pro forma invoice is what they call it. And I had to send that to the accounts or the finance manager to pay that, so that I can get the bearings delivered to the person, the flange bearings delivered to the person who's manufacturing the Vesconite bearings, so that he can actually try it out to see if it works out. Okay. I had to put that fan shaft and impeller on hold. There was some FEA analysis done, and it showed that this impeller would not be able to withstand the temperatures unless we made certain reinforcements to it. And because the impeller was increasing in weight, and because of the reinforcements, the shaft also had to be altered. Last week I initially thought that it was a bit of a waste to do this. I thought maybe these were extra things that didn't have to be done. That case of like diminishing returns, where the thing will work, it'll perform reasonably well, and then anything extra that you put on, it's just wasting time in design work, and the improvements that you're making do not equate, or the improvements that you're making are not worth the amount, like the actual final improvements are not worth the time it takes to make those improvements. Okay, but nonetheless, I found out that what the engineers were supposed to do, the engineers who designed this fan, what they were supposed to do is conduct an FEA analysis, because the operating temperature is above 400, well, it's 400, it's above 400 degrees. Whenever the operating temperature is above 400 degrees, you have to do an FEA analysis on the shaft and impeller, actually on the casing as well, to see if it will perform. The selecting tool that we use to select these fans, it does say that the fan can operate at that temperature, but it says that you have to have an FEA analysis to see what reinforcements need to be made. So I had to put that shaft and impeller on hold. Fortunately, this is one of the less critical components that we're manufacturing for the client, so it shouldn't be too much of an issue if there are delays. I don't think that there will be delays. This shaft had to be forged, so I had to phone the shaft manufacturer and tell them that this is the issue and we need to put this shaft on hold. His main concern was that the length does not change, that if we do change the shaft, the length must remain the same, and the biggest diameter needs to remain the same as well, which is reasonable, because you can't now, if material has already been cut for this job, you can't now get a longer material, and you can't get a thicker or wider in diameter material. So fortunately, that shaft has not been manufactured yet. That was the only concern, that the the biggest diameter hasn't changed, and the length does not change. The impeller, that wasn't too big of an issue. The impellers tend to be much quicker to make than shafts for some reason. It's mainly because the shaft has to be forged, that the lead time on the shaft is quite long. The impeller, the lead time is not so long, so it's not a big deal for us to put it on hold for a little bit and then manufacture it once we have the drawing sorted with those modifications. Then also I had to get some information for spares. The client requested that we compile a list of spares that are needed for this system, for the different fans that we're providing. I had to put together a list of spares, phoned up some people that we had ordered some of the components from, got quotations from that, and was compiling the list of spares. Actually, it takes quite a long time to get these things. People are very busy, and there are many other things that need to be done that seem to be more pressing. But like last week, even the week before that, we were already asking for this information. There's some fans that we are not making ourselves, but we have sort of outsourced to other fan manufacturers or fan suppliers, and so they have to provide us with a list of spares. I actually asked for these things for their list of spares, and the pricing as well. A week ago, even 2 weeks ago, still waiting for some of that information, but it's coming in. Then I had to put together an RFQ. That's a request for quotation for Cradles. And there's just, it's a vast difference between the drawings for the Cradles and the drawings for the fans. The fans are German designed, German approved, and so they have all these different materials, and we were facing all these issues of getting the right materials. Not only that, these fans are process fans, and so they operate in an environment that's very corrosive, very high temperatures, and so it's important to get the right materials. However, for the Cradles, this thing is like local materials, like standard materials, and so easy to manufacture. So the request for quotation that I sent out yesterday were for 4 Cradles for 4 fans that we're manufacturing, and so I sent out these requests for quotations, and I'm hoping to get them by Friday. If I get them by Friday, I can look at all the different pricing and what everybody's offering. Even the corrosion protection specification on this is like standard, like red oxide. None of this like hectic corrosion specifications that are required for the fans and so on. So it should be very easy for the sub-suppliers to quote on that, and it should be quite quick to manufacture these things. I'm not expecting any problems, or the material problems or time delays that we experienced with procuring the fans and the fan casings and the shafts and so on. And then lastly, I got some general arrangement drawings. I received that from a drawing office for a different project. There were some errors, this PDF document, one PDF had like this black line through it, didn't know what the issue was. It's possibly happened as a result of like printing to PDF from from the drawing software. So in a nutshell, that was my Monday and Tuesday. Yeah, lots of emails, lots of phone calls. Maybe one more thing. There was an email that I received from somebody who's supplying us what we call anti-vibration mounts. These are basically like springs that sit underneath the fan, and they prevent excessive vibration. And so the client wanted to know, what is preventing this thing from moving sideways, moving back and forth, and not just preventing vibration. And so we got some information from the manufacturer, actually the person who selected the springs for us. I still have to take a look at that, go through it, and yeah, prepare myself to meet up with the client and be able to explain to them what the issue is, or not really what the issue is, as to why this thing actually will work as intended. Yeah, so like I said, that was my Monday and Tuesday in a nutshell. Okay, so what did my Wednesday look like? When I got to work on Wednesday morning, I looked at a overview, or I just went over a email that I received from one of our engineers, and he told me that there was an issue with a shaft. Well, let me first start with just explaining to you two projects, the two main projects that I'm busy with. The first one is a process plant. We are supplying 6 fans for that process plant. 4 of them we're doing the design and procurement in-house, and for 2 of those fans it's done by sub-suppliers. So for the process fan project, there was one of our fans that we're providing. The shaft was interfering with the bearing housing. So you have the shaft. It kind of has a wide flange, and then like it steps down as you go to the ends of the shaft. And on both ends are actually bearings. And so on the one side you have the bearing journal. That's where the bearing sits. But then there's a shoulder. It's part of the shaft. There's a bit of a shoulder, and the shaft seal sits there. This is like a seal that prevents any gases from leaking out of the fan casing through the shaft area. So that's where the shaft seal sits. So that's important to have that machined properly to a good finish, and then also the right size as well. But then there's a part, the journal where the bearing sits. But now you have the bearing, but then you also have the bearing housing, because these are oil bearings. So there's the housing, and inside the housing there's oil. So now the housing, part of it sits on the one side of the journal, and part of it actually sits on this other section of the shaft that is the diameter that's needed for the shaft seal. So there's a part of the housing now. So the part of the housing that sits on a bigger diameter, we realized that the bearings that are required for this shaft, the housing is actually going to interfere with that section of the shaft. The housing requires a 70 millimeter diameter, and the shaft actually at that section is actually 80 millimeters. So what we needed was either to modify the bearing housing so that it can accommodate that 80 millimeter shaft diameter, or we need to modify the shaft. Now there are issues on both sides of this. On the bearing side, we're moving now from a standard manufactured bearing to a special bearing, and that will take some time. That'll take some design work. The modification process is not so simple. You have to make sure the thing fits, and if you do modify the bearing and it breaks while you're modifying it, then you have to order another bearing, and that's much more money. On the shaft side, if you modify the shaft, then you have to do calculations to make sure that the shaft is actually going to be able to perform as it needs to. If it's not going to experience too much stress now at the smaller diameter, and as a result fail. So I sent that out to one of our technical experts to just evaluate and to find out what would be the best option. Of course, our preferred option would be to modify the shaft. We have to make sure that the shaft is able to handle that load now in that area, in that smaller diameter area. So I got that back from the technical expert, and he showed us that we can actually modify the shaft. We can reduce it to 70 millimeters to a maximum of 60 60 millimeters long. So that's very helpful, and so we're going to make that modification. We're going to send that modification to the shaft manufacturer and tell them to do that. This, of course, is okay to do that because we're reducing the diameter, we're not increasing the diameter, so it's not too urgent or too imperative, that we get this detail to the shaft manufacturer like ASAP. I can get it to him, maybe. I mean, even after he's machining it, I can actually give it to them. But of course, I do it as soon as possible. So we sorted that issue out. I had a meeting with the company's called Nucleus. Actually, what they do is they do transport logistics. So the other project that I'm working on is a mine ventilation project. So this is it's just basically extracting air from a mine, and then somewhere else on the mine there's an area where where air can come in. So you have an extraction fan. So what it does is it forces a draft, or it induces a draft rather. It's sucking on the side, and anywhere where the other holes in the mine, the other shafts and so on, other mine shafts, air will now come in, fresh air will come in, and then everything else will be extracted from this ventilation. So process project and then ventilation project. So for the ventilation project, this project is actually in an African country, high up African country, the DRC, Democratic Republic of Congo. And so what happens is this company, this transport company, they actually do the transportation. They provide the trucks, and there's also a lot of checks that have to be performed before you go. I mean, traveling through all these different countries, and they have to make sure that what we said we're going to export, we are exporting. What the value of what we're exporting, that actually matches what we're invoicing. And so then when it gets that side, then there's like an import, and it's all those different checks that have to be done over there. So I had a meeting with them just to give them an idea as to what the project is and what typical sizes of the items are that we're producing, producing and exporting to the mine in the DRC. And so they indicated to us what they need from us. They indicated to us what's very important to get done as soon as possible. One of the most important things is what they call a pro forma invoice, and this basically is just an invoice that indicates what the value of everything and what you're actually going to be invoicing the client for what you are manufacturing for them. So that's one of the things that has to be approved, and it can actually take you 2 weeks to get that approved. So you don't want to get that done only when the things are ready to be shipped. You want to get that done as soon as possible, so that by the time you're ready to ship, that's already done, and you can load the items on the truck, and they can be sent to site. You don't want that to keep you. Okay, so we had a meeting with the transport company, and then the QCP, so quality control procedures. For every single item that is being manufactured by a sub-supplier, the client requires a document that lists, everything that's going to be done, all the quality points that are going to be looked at, and then the client has to indicate where it is, where we have to have a hold point, where we say we're stopping manufacturing, so that the client can come take a look to see if everything's okay, if everything matches the drawings, if the paint spec, for example, matches the quality, the paint spec that was required. If the machining matches the drawings, or even the specification that was required, the surface finishes, all that kind of thing. So what I had to do was I had to get all these QCPs now from the sub suppliers. Actually, we received them, but now I had to renumber them according to the project number supplied to us by the client. So I have to do that. The client, you indicate to them what you intend to submit, and then they give you document numbers for every single one of the things that you're going to submit. And so I had to make sure that all those QCPs had the right numbers according to the numbers that were provided to us by the client. I also had to follow up with some of the sub suppliers. I mean, there's a supplier that we have who's ready to manufacture, but he hasn't submitted QCP. Now, of course, we can't have that. We have to have a QCP that's approved by the client in order for manufacturing to start. So it's something that can hold up manufacturing, but it's very important that the client has a QCP and that it is approved, so that we make sure that we meet the client's requirements. Okay, for the ventilation project, I sorted out the payment for bearings. Like I said yesterday, the previous day, I had some issue with our account, with the cash on delivery versus credit account. But anyways, managed to sort out the payment, made sure that things were paid, and then hopefully the bearings will be delivered sometime today. The flash bearings hopefully will be delivered today to the person who's making the Vesconite bearings for us. He's gonna remove the rolling element bearings and put the Vesconite bearings in there. And then then I requested a quote from the bearing people. Okay, so I actually requested a quote for other bearings for the process project last week already. And man, these guys were just taking a long time. And then Monday I called to find out, hey, what's happening? They said, no, this guy's not in. The guy who was giving me a quotation, they said he's not in. I phoned Tuesday, he wasn't in. It was okay because our project coordinator wasn't in, so it was okay that I didn't have a quote yet. I wasn't going to be able to place the order anyway. But yesterday she was in, and I had to make sure that I get that quote. Unfortunately, I didn't get the quote because yesterday also the guy that was preparing the quote to me wasn't in, so I had to send the list of requirements to another person who's not going to quote, and then that guy also, he was quite busy yesterday. So today I'm not going to be at work. I'm actually attending my sister's wedding, but tomorrow I will make sure that gets sorted out so we can get those bearings ordered. Okay, and then I had a meeting with the client for the process project, and we indicated to them that there was going to be some changes on one of the process fans. And one of the big concerns was, okay, if there's going to be changes in the layout of this fan now, is there going to be changes in the foundation? So in the meeting, I actually called up one of our engineers and I said, hey, is there going to be this change? And he assured me that there wasn't going to be any change. There was just going to be a change in like the fan casing dimensions and so on. It's a big issue, of course, if the foundation had to change because it's already been laid, and that'd be really bad. Another thing that they highlighted to us was that we have actuators that control the amount of air that's coming into the fan, and because we haven't ordered those actuators yet, they were quite concerned that this late in the project we haven't ordered those actuators yet. We actually were close to ordering them, but when we sent the specification to the client, they highlighted to us that these things have aluminium in them, and we don't want any aluminium on the plant at all because of the nature of the chemicals that are on that plant, and the aluminium will just completely get disintegrated. So that's why we have to have a change in the actuators, and now taking some time. We have to have a special material. It's not really a special material; it's just a different material. We have to use stainless steel instead of aluminium. So we have to get those actuators ordered as soon as possible. Otherwise, we might be late in the project. Then also I had to send updated general arrangement drawings and foundation layout drawings to the client for the ventilation project. So just to give you an idea about the size of these projects, the process project with the 4 fans, that one is around 17 million rand in value. That's probably like about 110,000. No wait, 1 million, between 1 million and 1.5 million US dollars. Another one's 12 million rand, so that's also about maybe 900,000 US, up to about maybe 1.2, 1.3 million US dollars. So that's the size of the projects. And that was my Wednesday.